discuss about the relief displacement and tilt displacement, right? So whenever you are taking photos from the aerial camera, right? So if you are taking photos from the from some height, no? So whatever objects are there on earth, right? So everything will be captured as a horizontal one. But if you take any tree or any some apartment or anything, right? So it will have some height, okay? It will have some height. So if you just moved on, so the down part will be at some location, top part will be at some location. There will be some difference, some replacement is there. That's what we are going to discuss in the today's class, right? Distortions or displacements, when it will come, right? What are the different types of distortions are there? We are going to see. This is the shift in the location of an object. Suppose if I am taking a photo from this point and my object is there some height, right? Suppose the electric pole top is A and bottom of the pole is B, right? So whenever I am capturing onto the camera, right? So like this is B and A. You can see some horizontal distortion is there, but actually this is only one object, right? One object, but in the horizontal what is called 2D peak, right? So you can see 2 points will come like this, okay? So that's what shifting in the location of the object, but location is this only, but we have some observing some shift, right? So which changes the perspective characteristics of the photo, right? Due to this, the perspective characteristic is going to change, right? So what are the different types of distortions, okay? So why it is going to happen? So film and print shrinkage, that is negligible effect, right? If you have this shrinkage of paper, that photo paper, there will be some distortion. Then coming to the second one, atmospheric refraction of light rays, okay? Even if light rays are passing through some atmosphere, it is going to bend and, okay, we will see that one. That is also negligible effect. Then we have image motion, then we have lens distortions, right? So next, okay, so we are going to discuss about many things regarding lens distortion. Small effects due to the flaws in the optical components of the camera system. Due to camera system, we have some mistakes, okay? So typically more serious at the edges of photo, okay? Next, radial effect from the principal point makes object appears either close or farther from the principal point than the actually they are, right? So actually whatever they are there, not due to this lens problem, it is going to separated or same 2 points will be merged at one location. Those kind of things will be happen. May be corrected using calibration curves. May be corrected using calibration curves. Next, examples: car windows, window shields, okay? Carnival mirrors. Due to there we can see this thing, right? So next, displacement, okay? Shift in the location of an object in a photo which does not change the perspective characteristics of the photo, right? We are going to see the position of an object already marked there, okay? Since one electric pole is going to have the 2 locations on the photo, right? So this is fiducial distance between object's image and true plane position caused by the changes in elevation. So now we will see what are the displacements are there. Okay, so here curvature of the earth, where due to this curvature now, so we can't take same points. Next, we have relief displacement and we have tilt displacement. Okay, so but in our syllabus we have these two, and the curvature of it is a negligible effect. We are going to neglect it, right? So here relief displacement is radial from the nadir, the center from the center line. Okay, so it will be radial. Okay, that side, this side. Then coming to the tilt. Tilt now, if we have not vertical, some other angle, there radial from the isocenter. Okay, so let us see about these two things in this today's class. Okay, major causes of non-uniformity in the scale within a single photograph, that is relief displacement and tilt displacement. The two are there. First of all, we are going to discuss about the relief displacement. See here, right? So this is the actually surface above the elevation, right? So if this is the point, actually it is there, but we have actual some height, no? So then coming to the here, you can see here the bottom will be marked here and the top will be marked here. Actually this is only one location or one object, but here it is showing two objects. Some distance is there, right? So you can see that is called actually the displacement, right? So this is the error in the position of a point in a photograph because of relief, right? So due to that due to relief we have the position is got changed. Now the positions of a point in the photograph which has a center projection is different from its corresponding position on the map. Actually photograph on the map, actually that distance will be there, that is due to the relief, right? So the radial from the nadir, okay? So it is radial means you can see here it is not directly from here, from nadir it will be a radial, right? Some distance is there, right? So now you can see here, if your photograph is truly vertical, right? Exactly that vertically you are taking now, and the ground is horizontal, right? Ground is horizontal. The scale of photograph will be uniform. Such photograph represents a two orthographic projection. Orthographic projection means, right, whatever it is there in 3D, actually we are going to get in a 2D, right? So from 3D to 2D we are going to project it, and hence there will be a true map of terrain. Then coming to the, when the ground is not horizontal, right? Not horizontal means like this. The scale of the photograph varies from point to point. Okay, so if you same thing you are capturing in the photo, you won't see these kind of undulations. Simply you will get a straight line in the photo. But due to that, the scale is changes a point to point and is not a constant one. Okay, since the photograph is perspective view, the ground relief is shown in the perspective on the photograph. Okay, some distortion will be there. Okay, every point on the photograph is therefore displaced from the true orthographic position. This displacement is called relief displacement, right? So you can see in the thing. So in this first photograph, you can see here, right? So they are marking like this. Okay, you can see here we are able to see some what is called an apartment, right, which is forming the isometric view. We are going to see top and we are going to see the bottom also. If you come to the next photograph, you can see it is a truly vertical, or it is taken from other side, it is truly vertical. These kind of changes we will observe, right, if you are capturing photos from the aeroplane, right? So these kind of changes we can easily observe. Okay, so here also you can see this is the apartment. From this side if you are seeing now, this is only one object. If it is not, if it is a vertical, truly vertical, you can see only this building from the top view. But if it is not truly vertical, this is one location, this is another location. Two locations, that means same building is having 2 points here and here. Okay, so if you are taking vertically, no, so in this photograph you can see able to see only one position, right? So that displacement is called, okay, so relief displacement. Okay, so here you can see we have points on the ground. B is there, some K is there, some A point is there. Okay, so it is actually on the ground level. But if you are taking a datum, the datum height for B is HB, this is for HK, and this is for HA. This is for HA, and their points, their same position on the datum. If you are taking, it is a B will be at B naught, K will be at K naught, A will be at A naught, right? So these positions if you are capturing in the photo from O, and if you are seeing on the photographic plane, so you can observe here, B will be at one location, B naught will be at one location, A will be at one location, A will be at one location, A naught will be at one location. But you won't see any changes in the point K since it is in the same line, right? So now whatever distance, since you can see here, B is on the ground level, B naught is at the level at datum, right? Datum, point on the datum. Here also A and A naught will be at the datums only, but in the photograph you can see some distortion is there, some same point it is got some displacement. Okay, that displacement is called relief displacement, right? So here you can see actually this is the lower point. Okay, so this will be exactly it will be this point. You can see the bottom will be marked here. That means this is inward displacement. That means exact position is moved somewhat inside. Then coming to the points which is above the ground level, top point will be here and the bottom point will be here. That means it is outward displacement. These kind of displacements we can observe in the case of photo taking from the aerial photogrammetry, right? So now to determine the relief displacement, we are going to consider this diagram. Here you can see here, we are going to take a actually a top of tower. So tower top is at A and it is at bottom at A0. Okay, so it is having a height of small heads, right? So and we are going to take from the nadir point from here. The radius is at a distance of r, right? So same thing will be taken on the photograph, right? So the top of A will be marked here and the bottom A0 will be marked as A0. Top A, capital A will be A0 on the photograph, bottom A0 will be at the small A0 on the photograph, right? So here from the center, the radius of A0 will be given as R0 and the position of A is given at R, right? So whatever this difference is there, right? So whatever difference is there, R minus R0 is going to give us the relief displacement here, right? So now we are going to find out this A minus what is called R minus R0, that is relief displacement. We know already that is relief displacement. That also we have to know now, right? Then only we will get exact values, right? The radial distance of A0 is the relief displacement of A. In the previous diagram, A0, the difference is called displacement of A, and B0 is the relief displacement of B. Then the K is not displaced, right? So you can see in the previous diagram here, right? Here we can see B0 for B, relief displacement of B. B0 is the relief displacement of B. And A0 is the relief displacement of A. K is not changing anything, right? So that's what he told there. Okay. Next, to calculate the amount of relief displacement, we took the thing, right? So that is R is the radial distance of A to K, and R0 is the radial distance of A0 to K. So that's what it is there in the diagram. Okay. So there we saw that. Okay. So here R0 is the distance between A0 to K and R is the distance between from A to K. From A to K. Okay. Next. So R0 is the radial distance of A to K. R0 is the radial distance of A0 to K. So finally, capital R is going to be given by capital R. That is a distance on the ground. It is a K0 into A0. Okay. So K0 A0 distance. Okay. So then from the similar triangles, right? So from the similar triangles, you can see here from the similar triangles, which triangle? This one. OKA A0. This is one triangle. This is one triangle. You can see. Okay. So from these triangles, please remember this. Here the distance is F. Okay. Same F is on taken here. That will be total heads. Right. So right here from the similar triangles, F by H minus heads, right? So F by H minus heads, okay? So now you can see F by, this is one triangle, this is another triangle, this will be equals to how much? R0 by which one? This R, capital R, R0 by R. That's why, see, you can see F by H minus H is equals to R by R, from which small r is equal to written as Rf divided by H minus H. Then coming to next triangle, okay, so F by H is equal to R0, from which R0 is equals to Rf by H. Hence the relief displacement D is given by R minus R0, where you substitute those values here. So Rf divided by H minus H minus Rf by H, right? So now we can see here D is equal to Rf by H minus divided by H into H minus H, but R we got value that this value, and this may be equals to R0 into H minus F. By substituting those values of R in the previous displacement, this equation, then this equation will be rewritten as R into H minus H by F into Fh divided by H into H minus H. Okay, so finally you are going to get a value of RH. Why? Because everything it get cancelled, you are going to get a final value of this. Okay, now D is again, this R will be substituted with another value. So from there you are going to get value of this thing. Okay, so now the relief displacement small d is equal to RH by H from the one equation, it may be written as d is equal to r naught into h by h minus h. Right? So this is the relief displacement given according to the formula. Right? Next, tilt displacement. Okay? So if a terrain is photographed once with a tilted photograph, tilting means some angle. Okay, it is not a straight one. Right? So then with a vertical photograph, both taken at the same flight altitude and with the same focal length, two photographs will be matched at the axis of tilt only. Same at the axis, same photograph will be taken on the same height. There will be, the center will be considered to one point only. The image of any other point not on the axis of tilt will be displaced either outward or inward with respect to its corresponding position on a vertical photograph. Okay, it is going to move. Okay, so tilt displacement is defined as the difference between the distance of the image of a point, right, on the tilted photograph from the isocenter and the distance of the image same point on the photograph from the isocenter if there had been taken without no tilt. That means the distance between points on the tilted photograph as well as the without tilt, with the tilt. If you take two photographs, so okay, so there the difference between the distance of the image of a point on the tilted photograph from the isocenter and the same point from the same thing. You can see next diagram. Okay, so here this is the untilted photograph. This is vertical photograph, and second one is the tilted photograph. Okay, so now if I am taking anything, right? So now actually the position is A. Normally on the thing position is A. Okay, so because of tilt. Okay, so first vertical photograph is this, right? A dash is the vertical photograph. A double dash is the tilted photograph. Now the distance between A dash to A double dash is called tilt displacement. Okay, so tilt displacement. Okay, but the axis is here. You can see this is same axis even for what you can say tilted photograph and as well as vertical photograph. Things are same, but the distance between the A dash, here you can A dash and A double dash. Okay, so the distance from vertical photograph to the tilted photograph of a same object, that difference is called tilt displacement. Right? So these are about the tilt displacement as well as the different types of displacements. Okay, so that's all for today. Thank you.